Hello everyone. I'd like to thank you for joining us today for our webinar on how to help your operator. Mac Solutions are the creators of the Process View Alarm Management. We offer software, services and training in all aspects of alarm management, and we're based in the UK. My name is James Fox. Having worked for iMac, Matricon and Honeywell in the alarm management arena over the last 20 years, holding roles in technical support, site engineering, training and sales, I'm now the product manager for the Process View suite. Joining me on this webinar is Ian Brown. Ian Brown is our alarm rationalization and services manager. With over 40 years experience in the process industries, Ian has held a variety of technical, maintenance management and consultancy roles, specifically focusing on alarm management for the past 14 years. With that, I would like to hand you over to Ian, who will take us through the bulk of this presentation. If you have any questions, you can key them into the interface on your screen, or wait until the end, where we will have a short Q&A session. Okay, Ian, over to you.
Okay, thanks for that introduction, James. Good morning, everyone. Thank you for attending the webinar. As James has said, we seem to have a good variety of people joining, different backgrounds, which is excellent. And the webinar today is how to help your operator. What can you do to help your operator, and do you really need to? We're going to talk about can they help themselves and what can you do. So it's all about helping your operator, your operators run your plants. Is there anything you can do for them? And what should you do for them? Okay, my opening thought is, if we're being honest, operators are important. I know there's lots of jokes about, oh, the operators, oh, they're just a bunch of people that do stuff. They're not really important. But actually, they're really important on your plant. They run your plant. They know how your plant works, probably better than you do as an engineer. And good experienced operators are even more important. They're the guys you want to keep. They're the guys you want to keep happy, because a happy operator manages a good plant, manages the plant well. So when we're talking about operators, the first thing I say when I do training courses for operators is all alarms are important. So with the good operators, bad operators, any kind of operator, the first reaction I get to this statement is fits of giggles. Ha 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 ha, you've not been on our plant. Okay, my statement is all alarms are important. They should be. The rider I've put under the bottom is they should be. There should be no alarms that are not important. That's the important thing to remember. And it's not acceptable for operators to have to put up with lots of alarms. They shouldn't have lots of alarms for no good reason that they don't have to do anything with, that are just there because they are. All alarms should be important. An alarm is there to tell you something, that something is going wrong that you need to mitigate. Something's not happening that should be, and that is important. Anything that doesn't tell you that there's something going wrong or you have to do something, it's not important. It shouldn't be an alarm. So we need to end up in the situation where that big red statement, all alarms are important, is true. That's where we need to end up. So again, an opening thought, JFK, President of the United States, was once quoted, or has been quoted, as saying, ask not what your country can do for you, ask what you can do for your country. He's said to have plagiarized that from one of his high school teachers, a very similar phrase. He changed it to suit his presidency. I'm going to plagiarize JFK for a second or two, and I'm going to say, ask not what your operator can do for you, ask what you can do for your operator. So I'm going to turn that round and say not country, but operator. So think about it. What can you do for your operator? The first thing you're going to ask me is, do I really need to do anything? Why? What do I have to do? They know what they're doing. The operators have been here. We've got some guys here that have been 10, 15 years, 20 years. They know the plant better than I do. They know what they've been doing. What do I need to do? Okay, Well, it may be that you've had some legislation changes or you've had some regulatory intervention, which means you have to do something. Think about that. Do you really need to do anything? They've been here a long time. But what about the law? If we consider in the UK, the COMA 2015 regulations, there's in Schedule 2, Regulation 7, the statement, the following matters must be addressed by the safety management system. The COMA 2015 regulations were updated in 2015. They are legislation. They were brought about through changes to in the EU, the European Union, to the Seveso directive. Seveso 3 came out, and in Seveso 3, which was enacted in law by the COMA 2015 regulations in the UK, this statement is here in relation to operational control. These things must be addressed by your management system. Procedures and instructions for safe operation I've highlighted in red. So you've got to make sure that your operators can you've got procedures there that your operators can operate your plant safely. That's important. And I've highlighted 4 words: and for alarm management. Those words were added to the COMA 2015, to the COMA regulations, added to the Seveso regulations. The paragraph C1, CI, was there originally, but the words and for alarm management were added in 2015. So there's a legislative requirement if your plant falls under the COMA regulations. In Europe, if your plant falls under the Seveso regulations, then there's a requirement in law for you to manage alarms. So you have to help your operators. You don't have a choice. In America, if you fall under the Code of Federal Regulations, which are law, legislative, there are CFRs, Code of Federal Regulations, and I can't remember the numbers offhand, where it says, and you must manage your alarms. So the law says you must manage your alarms. So do I really need to do anything? Potentially, you don't have a choice. So the question you're going to ask now is, oh, I have to do something, but what? How do I know what they need? Because, as everyone will tell you, operators complain a lot. I'm joking there in case there are any operators actually listening. Yeah, they tell you things. But how do you know what they really need to do? Well, the first thing is to carry out a benchmark assessment, which is a gap analysis. Now, as an alarm management consultant, I'm naturally going to say, I can do that for you if you pay me some money. Okay. And as part of that assessment, I'm going to identify things like alarm rates, nuisance alarms, whether you've got procedures in places, whether you guys are trained properly or not. I'll do a full assessment, take a couple of days on your site and write a big report, tens of pages long, 30, 40, 50 pages perhaps, with prioritized actions and recommendations to help you comply with legislation if necessary, comply with the standards. I can do that for you. Now, naturally, I'm going to say that. However, if you look in the EMEA guidelines, there are 2 sections where there's an operator questionnaire. Now, the operator questionnaire is part of the assessment that I do. I use some of the questions. I've got an awful lot more questions, a lot more things I delve into than what's in the operator questionnaire, but it's a good starting point. It's a small part of an assessment, but there's some information in there. There's a usefulness questionnaire about alarms that are received by the operator. Are they useful? Are they a nuisance? Do they have to do anything? So there are 2 questionnaires that you can actually look at without having to pay me to come and do your job for you. Of course, I would like you to, but that's by the by. But there are things you could start to ask, and you could print those questionnaires out and ask operators to fill them in. The difficulty is, will they fill them in honestly? Because some of the questions operators can interpret as, why are you asking this? Are you trying to reduce numbers? And that's part of actually managing that thought. is part of a benchmark assessment, not just providing questions. But you need to find out what you have to do to help them. So in your guidelines, there's a beginning. Actually, what you really need to do is carry out a benchmark assessment, get an independent person that's not on site to find out what is actually really required to help you manage alarms and to help your operators. So when I do a benchmark assessment, typically what I find, the things that you need to do to resolve issues, A, to comply with legislation or the standards, or B, to improve things in general. Typical issues are training, lack of training, processes and procedures, not known, can't get at them. Okay, where are they? Do people know where they are? You've got far too many alarms because they've just been proliferated. People have just added them for no good reason. They're not prioritized correctly. There's a heavy alarm load. The operators don't have sufficient time to respond to alarms before the unintended consequence happens. You've got nuisance alarms, lots of standing alarms that clog up your displays, alarm configuration things not linked to displays, so they can't easily access the measured variable that's in alarm. They've got to look to find it. All these kind of things are the things that you need to resolve to help your operators run your plant safely and effectively. So first steps in how to help your operator. What do you need to do? Well, a former prime minister of this country, of the UK, had a mantra: education, education, education. And yeah, he's right. And although he didn't know he was talking about alarm management, it's valid for alarm management. Get your guys trained. Now, I'm sure many of you will say, our guys are trained. I'm talking about training in understanding and appreciating the need for alarm management, not in how to operate your plant, because that's where most operator is focused. This is what you need to do to operate the turbine, run the power station, whatever. You train people to do that, and alarms are just there. You have to deal with them. So the guys need to understand why it's important to deal with those alarms rather than just click the button to acknowledge them and move on. As part of the training course, what is an alarm? And you'd be surprised when I ask this question and start giving examples when I do operator training courses, how many people don't actually understand what an alarm is. And how many engineers on plants? It's a noise that tells the operator something's happened. But is it really an alarm, or is it something that's just nice to know? Actually, operators often don't really appreciate what an alarm should be and what priority is. Again, operators often don't appreciate and understand what priority means. Priority on many, many systems is indicated by a difference in color. You might have a red alarm for a high priority alarm. You might have a yellow alarm for a low priority, a blue, whatever. To many operators, color is just something that's there. It's just colors. It doesn't mean anything. It doesn't tell them that the red ones are more important because they haven't been trained properly. And actually, I did an assessment a few years ago where I was told they didn't know why I was there because we only have 1 or 2 alarms a day. And they had a big screen television on the wall with their alarm list. There was 1 alarm flashing in the alarm list, and it was a purple alarm. It didn't say not important, by the way. That's my interpretation. It was flashing away on the screen in purple. I said, you've got an alarm flashing there. Oh, yeah, it's been like that for a long time. We don't know what it is. I said, well, what's purple? I don't know. We've never been shown how to use this system. 2 or 3 years ago, they moved the control room from over there to in here, and we got this system, and we've not been told how to use it. We just do things. I said, so what is purple? We don't know. I delved around as part of my assessment, and I found manuals, and purple was actually a plant critical alarm. This was from a high integrity pressure system. And it was flashing. I said, acknowledge that alarm, would you? Humour me, please. They acknowledged, 10 seconds later, around about 10 seconds, the alarm came back again. I said, acknowledge again. It came back in about 10 seconds. They had an alarm happening once every 10 seconds, approximately. That's 6 alarms per minute. If we think about the alarm rates we all quote is alarms per 10 minutes, that's 60 alarms per 10 minutes. We try and get things down. The ideal is less than 1 alarm per 10 minutes. They had an alarm, one alarm, that was generating 60 alarms per 10 minutes. They didn't know what it was. They had no idea. They didn't realize it was a critical alarm. Clearly it wasn't, because the plant wouldn't operate if it was, but they didn't know. So they hadn't been trained on how to use the system to start with and what alarms really meant. So how can they improve things? How can they make their working environment better? They turned the alarm sound down, so they just had to look for things happening rather than being alerted because the noise alerted them, the sound alerted them to the fact there was an alarm. They just had to keep looking. So if they have lots of alarms, it's going to be a noisy system. So I deal with, when I do the alarm management training courses for operators, how can you help yourselves? Now, often operators will say, that's not my job. That's the job of the engineer, of the process engineer, the C&I engineer. It's nothing to do with me. But I get them to understand how they can actively help to improve their own working environment. And when I talk to operators, don't forget other personnel. What about maintenance guys? What about warehouse people? I'm sure many of you won't even consider warehouse people. I'm talking here about tanker offloading, that kind of thing. And contractors. Contractors, many companies will use third-party contractors, third-party configurers to actually write the software, modify the software. Do these guys that you bring in, do they understand alarm management? Do they just proliferate alarms because it doesn't matter? I've given you extra alarms. I'm sitting in a house a couple of 100 miles away from the plant. If it blows up, it's not my fault. Do they actually understand what they're doing? So think about other people. When you're on the training courses, I like to try and get people certainly for the operator training course, I like to try and get maintenance people, warehousing, if you have offloading people, to get them to attend the same course. Because often other people don't consider how their jobs will affect operators. So how does everybody else affect an operator? That's something you need to think about when you're thinking about how to help your operators. For example, alarm systems, they need maintenance from time to time. Okay, so what happens when you maintain a system? Does that affect the operator? Other operations, I've mentioned tanker offloading, daily boiler blowdowns. I worked on a chemical plant for 10 years and I was maintenance manager there. We had one of our maintenance guys used to do a daily boiler blowdown. Go and blow down the boiler. When you blow down the boiler, the water level drops. You get a low level alarm. We only had a common boiler alarm. Now, normally the guy would actually call the control room. I'm going to do the boiler checks. Great. So the operator knows when he gets a boiler alarm, that'll be Chris in the boiler house, where there's no radio contact and no internal phone. But he knows Chris is on the way. So that's that alarm. If that alarm happens normally, you've got no water in your boiler, potentially there's a potential explosion. They need to get an operator to go to the boiler house, which is going to take 2 or 3 minutes to go in. You're going to take them away from doing important things. So by not telling the operator, you're putting a whole scenario in operation that doesn't need to happen. The operator has to respond. He shouldn't need to. And what about remote site access and maintenance? If you've got an above ground installation, so gas pipes that come out the ground, there are regulators and they go back into the ground. What happens if somebody breaks into that site and all of a sudden does something that causes an alarm? What happens about water treatment plants, for example, if you don't know that somebody's there? What happens? Do the operators have to get someone? These remote sites could be, for example, tens of miles away, could be 50 miles away from the actual control room. When you're talking about water treatment plants, above ground installations for gas regulators, etc., they're unmanned, there's nobody there, all of a sudden alarm happens. So going to site, carrying out maintenance, other types of things, even on site, how many of those tasks, these are questions I ask on the course when I do training for operators and other personnel, how many of these can be carried out without telling the operator? Okay, the answer to that is all of them can be. How many actually are carried out? This is where I try to get the guys to be honest. How many of them are carried out? A lot of people don't want to say, oh no, I always tell the operator. Yeah, okay. And how many should be carried out? Well, the answer to the first question is all of those can be carried out without telling the operator. And the operator gets alarms that he has to put in place actions that he doesn't need to do. How many are carried out? I wouldn't like to say what percentage of these tasks are carried out. Could be 10%, could be 90%, could be more, could be less. I don't know. But how many should be carried out? The answer to that is none. When you're carrying out those kind of tasks, you should always interact with the operator so he knows what's going on. He's in charge of the plant after all. So think about that when you're doing training. Don't just train your operators, train your other personnel. And obviously, all of the tasks that all these other personnel do and the operators, there should be written procedures. It's in the 2015 COMA regulations. You should have procedures for safe operation. So you should have those things. But do people actually rigorously follow them? What about maintenance of equipment? Do the maintenance guys tell the operators they're about to do something? Apply the appropriate inhibits, overrides, deselects, whatever? Do they actually tell the operator they've completed the work and they're returning the equipment to operation? I'm finished. Any alarms you get now are genuine alarms. It's easy to walk away from a job and tough job, big job, taking a long time. Oh, I could do with a cup of tea, and you go and you leave it. The operator doesn't know you're finished, and all of a sudden an alarm happens that has the potential to cause a major incident. Oh, Bill's still doing that maintenance. He hasn't told me he's finished. That'll just be Bill. All of a sudden you have an incident on your hands because people aren't following the procedures. Do they test the alarms when they've completed a task? How many people actually retest the alarms to make sure they're working, that what they have done hasn't compromised your plant? Buncefield, I've highlighted in blue there, was the largest explosion since wartime Britain. There were some aviation fuel tanks exploded. Why? Guys had done maintenance on a level control, on a level transmitter on the roof of an aviation fuel storage tank. They locked the transmitter in place to do maintenance. When they finished, they forgot to unlock it. They left it in the locked position. So the transmitter didn't report to the operator that the tank was overfilling. The tank overfilled. There was a huge explosion and fire. I don't know if everyone remembers Buncefield, but it was the largest explosion and fire since the Second World War in the United Kingdom. That was because they didn't test the alarm. Finished the job, went away. The operator didn't know they'd finished. There were a lot of other things happened. It wasn't just that particular thing, but there were a lot of other things came into play there. But the operator didn't know. He had no way of knowing because the level alarm didn't actually work. It didn't generate an alarm because it was out of position. And what about working at remote sites? Do they inform maintenance people, especially contractors, the operators before they enter site, when they leave site? What about the role of emergency services? I've worked on quite a number of places where around the area there are armed response patrols. When you turn up, if you park your car on the side of the road for a quick cup of coffee from your flask before you go into site, I've had it before where I have a knock on the window within a couple of minutes of stopping on the grass verge, a knock on the window and a guy with a submachine gun. What are you doing here? Oh, I've just stopped for a quick. You can't stop here. Have you not seen the signs? And they actively patrol. But consider, for example, a water treatment plant. What happens if the operator doesn't know that someone is going into site and a hatch alarm activates? It's because the guy's gone into site and he's opening the hatch genuinely. He's forgotten to disable things. He's forgotten to tell the operator. All of a sudden, a hatch alarm opens. Is there anybody there? Should there be anybody there? We don't know. Okay, potentially you might have to get the emergency services there because it could be someone that's broken into site, has opened the hatch with the intention of poisoning the water supply. If the operator knew the maintenance guy was there on site, he would know that everything was fine. If he doesn't know, then potentially you may have to bring in the emergency services. Potentially an armed response unit turns up with a guy doing his job. All of a sudden he's got a gun pointing at his head. Think about that. These are the kind of things that people often, maintenance guys, tanker offloading guys, they often don't think. So make sure to help your operator, get your other personnel, third-party configurators, get them trained as well to understand the importance of their role in alarm management. And as I say, following procedures. You have to have procedures if you fall under the COMA regulations. It's a legislative requirement. Following them, beg your pardon, is important. Does everyone know where they exist? Do they have access to them? I did some training courses for 3 sets of operators a couple of years ago. In fact, 5 or 6 years ago, actually. And when the engineer was in the room, I said, so do you have access to these procedures? No. Well, they're on the H drive or whatever drive. Yes, said the operators, but you don't give us access to the H drive. All we have is one common operator email account. We don't even have individual accounts. You won't let us have access to that. How can we print these procedures out? And remember, a printed procedure is no longer a controlled document. The procedure could change while you have that procedure in your hand. So these guys need to have access to these things. Did they have access? No. Did they even know where to find them? No. So how can you expect your guys to follow procedures if they can't even access them? While I was talking to the guys, I actually had an operator tell me, this is what we've been told we have to do, which kind of followed the procedure that the engineer at the front of the room had a copy of. Yep, I said, well, that kind of follows in with what you should be doing. When I did the 3rd training course, one of the operators said, oh, I don't do that. It's a lot of hassle when we shelve alarms. Somebody shelves a bunch of alarms on the shift before me. They auto unshelve when I come onto shift, and I have to deal with a whole bunch of alarms, decide what to do with them. I spoke to the vendor, the control system vendor, and asked his engineer, is there anything I can do? He showed me how to shelve them, and they don't unshelve at the end of the shift. That's a lot less hassle. This guy had shelved a bunch of alarms that nobody knew about, and that's not a good thing. Potentially, he's hiding alarms that other people are going to rely on. I'll get this alarm if anything's going to go wrong, and it's not going to happen. Potentially, you're hiding incidents. So make sure those procedures are being complied with. Audit, follow through. Ask the guys what they're doing. Watch. This is what I do in part of a benchmark. Watch what the guys are doing. They'll tell you they do one thing because that's what they should be doing. Actually, watch them in action. You might find they do something entirely different. So just make sure that you audit those procedures. It's great to have 10, 20, 50, 100 different procedures that cover absolutely everything. We've got everything in place, a procedure for absolutely everything. But if nobody knows where they are, nobody follows them, complies with them, they're absolutely pointless. So you need to make sure that you audit that what the procedure says is what the operator does. Audit the procedures to make sure they're correct. Is the procedure still valid? We've upgraded, we've changed our control system. We can't do that. That's why we don't follow the procedure. The procedure is wrong. Make sure the procedure is correct. So audit the procedures. And auditing is, of course, a requirement in the standards. And if you have to manage your alarms, do you comply with the standards? That's an issue, compliance with the standards I did a webinar on a few weeks ago. So think about that. So what else can you do? Training. I can't stress training for your operators and other personnel is essential. But what else can you do? Listen, your operators will tell you what's wrong. Often they're keen to have things improve because it affects their working environment. We've got things going wrong and you need to do something. Listen to your operators. They know when something's wrong. They know probably what needs doing. Potentially, they don't know how to do it. They don't know how to configure a system. That's fine. That's not their job. But they will know that something's wrong and tell you. When they tell you something, do something about it. Don't just listen and don't just hear. Listen to what they're saying, do something about it, take an action, and communicate with the guys. It may be you can't do something immediately, we have to put it off to the shutdown, but in the meanwhile, we're putting this mitigation in place. This is what we're going to do instead while we wait to get that fixed. We can't do it just now. Potentially, you may look at what they're telling you and say, actually, there's nothing we can do. It's going to cost £5 million to do that. We're going to have to work around this, do something. We can't fix what you think is wrong, but tell them why. Again, on the batch plant I worked on for 10 years, I had operators come to me, oh, can we do this? I've mentioned this loads of times. Oh, I'll look into it. When you look into it, there's a good reason why that wasn't done, which sometimes operators, as good as they are, may not consider why you can't do something. So keep communicating with them, because I've often heard said to me during benchmark assessments and while I've been doing rationalizations, while I've been doing all sorts of work on plant, I've told them nobody ever listens, nobody ever does anything. So the operator tells you what's wrong, you've heard it, but you don't do anything. Why should I care? And that's what comes. That's the mentality you instill in operators. They've told you what's wrong, but it's a lot of work to do. I can't be bothered. I'm busy. Oh, they'll sort it. No, they won't. What you do is you reinforce this. Why should I care? I've told them there's something wrong. They're not bothered. Why me? So this is something that I hear time and time again. Because you don't do things for operators, they lose interest. And remember, good operators are really important people. So one thing you can do to help your operators, obviously, is rationalize your alarms. At the start, I said one of the things that you need to potentially address is the number of alarms, the total alarm load. And this is really important to make sure you have the right number of alarms at the right time. Not too many alarms, just the alarms that are required to run your plant safely and effectively. But how long will that take to rationalize your alarms? It could be a long and tedious process. And do I have to do all the alarms? It's a question I get often asked. I don't have to do all the alarms, do I? I'll just do the top 10 nuisance alarms. I'll just do the high priority alarms. I've had a notification, a notice from the HSE. I've got to rationalize and document my high priority alarms. That's all I have to do. I've only got 200 high priority alarms. That's great. I can do that quite quickly. Is that the right thing to do? No. Do all your alarms. In the standards, to comply with the alarm management standards, ISA 18.2, IEC 62682, they both do the same thing. They say you have to do them all. I'll show the statement in a second. But if you rationalize all of your alarms, your plant will benefit. Your operator will benefit because all of a sudden you don't have all the nuisance that they have to deal with. They can concentrate on managing the plant. Potentially, I've often seen between 40 and 60% of alarms disappear because they're not alarms. People have configured them, there's no need. If you look in the standards, the statement I mentioned a second or so ago, the standard says rationalization is a process to review potential alarms, and to document the rationale for each alarm. So the standard says you have to document the rationale for each alarm. That's every alarm, not just the top 10, not just the high priority, which are configured currently as high priority and may not actually be high priority in reality, but you've got to document the rationale, the cause of the potential cause of the alarm, the consequence if you miss the alarm, what the operator needs to do to respond to the alarm. You have to do that for every alarm if you want to comply with the standards. And compliance with the standards may be a requirement of any written notifications from a regulatory body. So think about that. It's easy to say, I'm going to take the shortcut and do the top 10, just high priority. But that doesn't really deal with your real problems. Because if you think about it, a nuisance alarm that happens tens, hundreds, thousands of times a day, does that shut your plant down tens, hundreds, thousands of times a day? No, it doesn't. It's a nuisance. You need to deal with it. Yes, deal with it. But where's the alarm that's actually going to trip your whole plant off and shut you down for 2 or 3 weeks? It's probably hidden amongst the lower priority alarms because it's not been correctly reviewed, it's not been correctly prioritized. So it's hidden in the lower priority alarms. So looking at your top 10 nuisance alarms, that's not really going to help your plant. And looking at your high priority alarms, when you review them, the vast majority of them become medium, low priority alarms or even events. And when you start looking through the low priority alarms, you often find something that says, whoa, this is really important. This should be a high priority or even a critical plant alarm. If you're only going to do top 10 or high priority, you'll never review that alarm. And all of a sudden, bang, the alarm happens. The operator misses it because it's meaningless, it's nonsense, and your plant shuts down. Or worse, you have an incident. So think about that. Dealing with rationalizing all your alarms. And any process that doesn't consider all the alarms is not true rationalization. If you do a subset, you've not rationalized your alarms properly. You've not done anything. If anyone comes to you and tells you that they can complete this process and rationalize your alarms in a couple of days, use our piece of software, we'll do this for you. Sadly, they're snake oil salesmen. They're not telling you the truth. They are not rationalizing your alarms. Some of the pieces of software may only look at analog alarms. What about the digital alarms, which often vastly outweigh the number of analog alarms on your plant? You've got a whole bunch of stuff you've not looked at. You've changed set points with these pieces of software. It's not rationalization, guys. As I said earlier in the slide, it could be a long and tedious process, and there are no real shortcuts. So, how to help your operator? Make sure they have time to respond to alarms. Priority is generally based on the consequence that will occur if you fail to respond to an alarm and the time the operator has to respond. So you need to consider those things during rationalization. Do your operators have sufficient time between an alarm occurring and the undesired event? Do they have plenty time to actually respond to that alarm? Okay, if you look in the alarm management standards, there's an alarm response timeline. I'm not going to go through this because you can look in the standards. I'm sure most people know about it. You have a rate of change. You consider the maximum rate of change of a particular process variable. How long have you got between the alarm occurring and the undesired consequence happening? Does the operator have sufficient time to respond there? That's great for analog alarms. But what about other alarm times? What about digital alarms? On a batch plant that I reviewed, at the end of a batch, an operator had to go into a pit below the reactor, connect up pipework, connect pipes to the reactor base valve onto a transfer pump. He had to do several operations and then push an enable button in the pit. The operator then had to get out of the pit, up some steps, across the floor of the reactor hall, avoiding the pyroban forklifts that were bringing in IBCs, raw materials, all that kind of thing, across to a hardened console in the hazardous area at the other side of the reactor hall, call up a graphic, and then say, start the transfer. They started the packing process. As the guy was getting out of the pit and starting to walk across the floor, after 10 seconds, the alarm occurred. A low flow alarm. Now, the low flow was a genuine alarm. What it meant was either there's no flow in the pipeline because the reactor has finished emptying, so there's no more product to transfer, so the transfer is complete, or there's a filter in line, the filter's blocked, and it's telling you there's a blockage in your filter you need to address. So the alarm was there for a good reason. But after pressing the button, the alarm was enabled after 10 seconds. It didn't give the guys time to get across the floor, which should have been 30 or 40 seconds, and the transfer did not start until the guy pressed the button on the graphic. So this alarm occurred every time. How difficult a job was that to deal with, to change that time from 10 seconds to 30 or even 60 seconds to give the guy plenty time, and then you start monitoring the flow. Not difficult. I refer to a statement I made earlier. When I was looking at these things, I've told them loads of times, nobody listens, nobody ever does anything, why should I care? All of a sudden, that operator's in the mindset that there are lots of alarms happening, nobody else cares about them, why should I? There's an alarm going off as I'm crossing the plant. Do I need to react to it? Oh, who cares? Nobody else does. And that's what you do by not dealing with these alarms. That was a very, very simple thing to deal with. Not difficult, but nobody did anything. The operators told them, nobody did anything. And of course, those kind of issues, that happened every time they transferred a batch. But it may not just be frequently occurring alarms. Now, frequently occurring alarms, nuisance alarms, you should be dealing with in parallel with your rationalization. You can look at your top 10, but you still have to rationalize your whole population. So you can take half a day or a couple of hours a day to look at nuisance alarms, which you should be doing on a daily basis anyway, to deal with faulty instrumentation, etc., while you do maybe 3 days a week of rationalization. So look at your nuisance alarms. When you're doing rationalization, you want to deal with duplicate alarms. Do I have 2 alarms telling me the same thing? I worked on a plant on an FPSO, actually, from an office in Aberdeen a couple of years ago. Every time an alarm occurred, they had 3 alarms because the guys configuring on that system, they had an analog input block, a PID block, and an alarm block. And each of those 3 software blocks had high, 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 low, and low, low alarms configured. And each of the 3 individual blocks had the alarm set for exactly the same value. So when they had a high alarm, they had 3 high alarms at the same time. Really? Deal with it. Get rid of them. Identify the alarm you want to keep, which type of alarm you want to keep, and make it consistent. What about alarms that aren't alarms? If you have a sump which regularly automatically empties, a lot of people make a high alarm at the operation point of the pump. The pump turns on at 70% of the sump. That's the high alarm. So when the pump turns on, an automatic action that's expected, an alarm is generated. The alarm should be higher than the pump, so that when the pump doesn't start, you then get a high alarm. Okay, think about those things. On the batch plant where I've just talked about the guys getting out the pit, they had a reactor at temperature alarm. So the batch process controlled the reactor throughout the batch, which might be 5 or 6 hours long. An hour in, it said, I've got to reaction temperature, I'll maintain this. It generated an alarm to say, at temperature. The operator had, oh, it's just at temperature. I like to know that though, but it's not an alarm. Think about those kind of things. I worked on a gas reception plant. I did a benchmark assessment about 3 years ago, and there was an LP flare drum rate of change alarm. If all of a sudden, in a particular flow, became a large flow, potentially there was a ruptured pipe or a leaking valve, and it was a plant critical alarm. So if the rate of change exceeds so many, whatever, per minute, per hour, whatever the actual engineering unit was, if there's a high rate of change, we've got an issue. Every day this alarm went off because it was an averaged calculation. The averaged calculation said, okay, between 5 and 10, that's 5. That's great. Between 10 and 15, that's great. That's 5. When it got to the end of the counter had to be reset from, let's say, 10,000 to 0. All of a sudden, we have a minus 10,000. We have a difference of 10,000. The plant critical alarm occurred. It happened every day because of this averaging calculation. The senior operator came charging out of his office while I was there. What's that? What's that? It had its own individual plant critical alarm sound. Oh, it's just the LP flare drum reset again. Sort the calculation. The operators became numbed to the fact that plant critical alarms happened and we don't need to do anything. I've told them about it. Nobody listens. Nobody ever does anything. Why should I bother? Why should I care? We come back to that. Think about when you're rationalizing alarms that sound but have no message. About 8 years ago, I did some work on a different batch plan to the one I worked on at the recently, and they had alarms. When I went to create some new software, because I also did software, the operator said, "I hope you're going to sort this out better than the current system." I said, "Why?" "Well, we got alarms that we don't know what they are." Pardon? Alarms would be generated, a sounder would enunciate, and no message appeared on the screen. When the software had been previously configured, they'd forgotten to put alarm messages in with a couple of alarms. So all of a sudden, an alarm would go whoop, 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 whoop. The operator had no idea what it was, and all they could do was stop the noise. They couldn't take any action. They didn't know what it was. They had no idea if it was important. So think about those things. Are your messages, are they there? Do they exist? Are they sensible? Are they adequate descriptors? Think about those kind of things. Standing and stale alarms. Stale alarms, standing alarms may be hiding, I've got a statement here, may be hiding a potential for invisible failures. What do I mean by that? I'll explain in a second. Again, look at your standing and stale alarms, review them in parallel with your rationalization. You don't have to wait till you get to your standing alarms in rationalization, which might be 2-3 months down the road. You can look at your list today and start dealing with them. So do those in parallel. These are things you can do in parallel with rationalization. And consider on your plant how many stale alarms do you have? Tens? Hundreds? How old are they? Are they days old, weeks old, months old? Are they years old? Sometimes you'll see an alarm, gas reception plant I worked on, they had alarms that were 15 months old. That was the last time the console was rebooted. They're actually a lot older than that. Seriously, genuinely, honestly, I was asked, "Where did you park your car this morning?" I said, "In the little car." "In the car, tiny little car park, you turned left off the roundabout and you came through the security lodge?" I said, "Yeah." "That's where those alarms are from. That was where the flash gas compressor used to live. We got rid of the flash gas compressor about 15 years ago. So those alarms, those standing alarms, those 4 pages of standing alarms that you see on the console, they're actually about 15 years ago." "Oh, yeah, we've told them." Nobody ever does anything. They just sit there. Every time we reboot the console, we get pages of alarms clogging up our display. It's actually the car park where you parked your car. There's nothing there now. How does this happen? Projects get done, flash gas compressor removed, but the control system doesn't change. The operators have to deal with stuff that hasn't been there for 15 years. Wrongly configured alarms. Think about these kind of things. The same plant that had the flash gas compressor, or rather didn't have a flash gas compressor, they had 2 trains, 2 compressor trains. They had bursting discs and 2 vents. They had double bursting discs. So if one bursting disc goes, you still have protection because you've got a second bursting disc. So if one disc ruptures, your vent is still not open to atmosphere. That was great, except on one train, they had 2 bursting discs in a graphic that showed healthy. So they were a light gray to say, look, there's a bursting disc here. When the bursting disc ruptured, it went red and generated an alarm. On the second train, there were 2 showing in red. I said, you've got 2 ruptured bursting discs. Oh no, we haven't. They're healthy. Yeah, it's been like that ever since they put this in. Those two are healthy and they're showing grey. Those two are healthy and they're showing red. It actually just needs the input inverting, but nobody ever does anything. Now, I said about the potential for invisible failures in my statement at the top of the screen. These were incorrect alarm states. So you had two bursting discs which showed ruptured in your standing alarm list. What happens when the bursting disc actually ruptures? Because the input is inverted, the bursting disc alarm will clear silently. So one bursting disc ruptures, you've lost 50% of your protection and you don't know about it because it's wrongly configured. Everybody knows it's wrongly configured, but nobody does anything. The third-party contractor, who I actually knew from a previous job, he wouldn't do anything about it because nobody'd given him a purchase order. The company wouldn't give them a purchase order because it was such a small job. So it got left. And how does that help your operator? There's going to be a rupture of a bursting disc on a plant that they know nothing about. When the second bursting disc ruptures and you breach your environmental permits, well, why did the operator do nothing about it? It's the operator's fault. No, it's the engineer, it's the configurer, it's actually not the operator at all. You could help them by actually doing that job, getting that work done. So think about sensible and consistent configuration. Make sure it happens on your plant. One of the cornerstones of the EMUR guidelines is usability, one of the 4 key cornerstones. So I've underlined there in the statement they make under usability, should be designed to meet the user needs. This means that the information alarm systems present should be easy to understand. A system I did in a power station in Ireland, I won't say north or south, the alarms for a low flow alarm or a low pressure alarm, the low actually said not high. It had been configured, it was an Italian system, they'd configured, it's not high, it's low. So when the alarm was normal, the actual alarm message said not high. Not high was low, i.e. it's low, it's not high. When it went normal, it said it's not high. How does that help your operators? What's there? The message on the screen is not high. Oh, it's not high. Not high is low. Okay, guys get used to this over time. They do get used to it, but it takes time to understand these things, and that doesn't help them run your plant. So think about that. When you're looking at it, do you want to change those things as you do in your rationalization? Think about that. Do you have a tagging philosophy? Do your tags mean anything to people? Make sure the tag names are relevant, meaningful to plant items on the plant for the operators. A system I did a benchmark assessment and kicked off some rationalization with, they had typical alarm tag names. Tag names were OG PLC V1233616. It was file card channel number in a PLC. It helped the configurator know where things were when he was carrying out the configuration. Oh, I know where that is in the configuration. When the operator needed to understand what this was, what plant item is it? Because the descriptor might be wrong. And let's think about that. How many times have I seen, oh yeah, it says T1 flow, whatever, turbine 1 high low flow. T2 flow whatever says turbine 1 low flow. Yeah, they copied the descriptors. It's actually turbine 2, but the operator needs to think about that. He needs to, is the tag right? Think about it. Make sure that these things are done. And the tag name I've highlighted in yellow, absolutely meaningless to an operator. Help the configurator. Does it help the operator prevent the plant from having an incident? Or does it help the operator save a couple of seconds when he comes in once every 6 months to do some configuration? What's more important? Your operator. Here's something I did with a water company. Their tag names were database addresses. Okay, we have database address there of B20979 wet well. Okay, yeah, great, fantastic. Helps the configurators, maybe, doesn't really help the operators. So usability, make sure your system is usable to help your operators. Here's a screenshot from an assessment I did about 18 months ago for systems in Azerbaijan. If you notice at the bottom of that picture, there's a horizontal scroll bar. When an alarm occurred, the operator had to scroll left and right or right and left to actually see what the alarm was, to understand what it was. So he had to scroll back and forwards just to even see and get the information he needed. In the information he got, we had priority, low, great. Date and time of when the alarm occurred, great. Doesn't need to know that instantaneously because he knows the time. But the name of the asset that was in alarm was, I've highlighted in red, mimics.process.electrical.400 distribution bus A. Does he need to know that? That's actually the process graphic hierarchy of where that measured variable lives. It lives on the distribution bus A graphic, which comes from the electrical process mimics hierarchy. The operator doesn't need to know that. He's got this huge piece of information that he has to scroll back and forwards across the screen. What he really wanted to know was the bit on the right. But even the bit on the right, to the end, it says .db from PLC underscore A. Does the operator need to know this alarm lives in PLC A or PLC B or console 3? No, he needs to know the actual tag name. And to compound things like that, really helpful for the operator, the message that arrived with that tag name, undecipherable tag name, was state changed from auxiliary circuit breaker to auxiliary circuit breaker, not from open to closed or failed to normal. It was from AUX-CB to AUX-CB. So even the alarm states were showing the identical thing. They weren't the on and off states. They were duplicated. That's not helpful to operators. Okay, over time, the guy will get to know, oh, yeah, that means it's tripped. They'll get to know that. But when you have a huge flood of alarms, this is not helpful to your operators. So make sure that things are configured consistently. As I said, one of the key cornerstones of Imure is usability. Look at those two tags I've got on there. Shut down in incinerator A and shut down in incinerator B. I know what they are because I've looked at them a few times. If you see that immediately, can you decipher exactly what it is? Think about the case. It's all in capital letters. If you think about motorway signs, traffic signs, they have title case. They have a capital letter and the rest of the word in lowercase. Consider the case of your alarm descriptors. Because the reason that was done for road signs, there was a lot of work done in, I think it was the 50s. They looked and said, if we have everything in block capital letters, it takes you longer to read the block capital letters. Because when you look at things in title case with a capital letter and lowercase, as humans, you look at things and you recognize patterns of letters. You identify words by pattern recognition. If you have a whole load of block capitals, you can't recognize the pattern. It takes you longer to read. It takes the operator longer to respond to the alarm. He has to decipher things and sit and look at things. So think about that. May not be done as you're rationalizing your alarms because that will increase the amount of time you take, but think about that. So seriously, consider changing the descriptors from uppercase if you can. And what about help for the operators? Add operator help. As part of your rationalization, documenting the rationale for each alarm, if you remember from the standards, you're going to have what the potential cause is, what the operator should do, what happens if the alarm is missed. Ideally, if your system will allow it, if you can add a response, a help file, a response file, so that the operator can click, double click, right mouse button, however, and get that information that he needs. This is especially important if they're infrequently occurring alarms, something that doesn't happen very often. How many times I've done rationalization, we come to an alarm that's configured, and you might have a couple of operators in the room, and they'll say, I've never seen that before, have you? Phew, I've been here 15 years, I've never seen that. I didn't know that was an alarm. They didn't know it was an alarm, so how did they know how to respond to it? It hasn't happened. They haven't seen it. Maybe another operator has, but they haven't. So how do they know how to respond to it? If you can put your help file there, you've rationalized it, you've reviewed it. It's not one of your top 10 frequently occurring alarms that you're just going to do nuisance alarms and rationalize. No, that doesn't work. This one they've never seen before. So think about that when you're rationalizing. And if you can, link your alarms so that it will take you directly to your process graphic where the measured variable, it actually offers you the most information around the process variable. So think about that. That's a great help for your operators. So there are lots of things you can do, getting rid of nuisance alarms, rationalizing your alarms, get rid of your stale alarms, especially the ones that have been there 15 years, guys. Get rid of the ones that are configured incorrectly. I beg your pardon. Excuse me, just a second. Get rid of all those things. Is it all worthwhile? I hear you asking. That sounds like we've got a lot of work to do simply to help the operators. It's a lot of work. What's the reward? Your plant manager's going to say, where's my return on investment? It's going to take you 6 months. It's going to cost £300,000, £1 million, whatever it is to do all this work. Where's my return on investment? When do I get my money back? Is it worth it? Okay, think about what if you do those things? You take that time, you spend that money. What do we do? It's a better and working environment. Your operators become less stressed, which is good. You don't have people going off with stress. You don't want to do that. You don't want that kind of thing. The operators can manage your plant rather than just servicing alarms because you've got rid of all the chaff. You've only got the necessary alarms to operate your plant safely and effectively. So now they can manage the plant. You have fewer trips, unplanned outages because there were too many alarms I didn't see. I couldn't stop it from happening. It's not your operator's fault. It's because you haven't helped your operator by reducing the numbers of alarms. So that's going to save you money. A plant trip costs money. Starting up costs money. So that's going to save you money. Potentially, it's going to reduce your regulatory interventions because you're no longer going to breach your consent, or you're going to breach consent many, many fewer times because the operators can respond to the situations that would cause a breach of consent. So think about that. Breaches of consent potentially cost you money through fines. Okay, so there are some upsides, not necessarily going to give you an immediate return on your investment. What happens if we don't? It's a lot of work, a lot of effort. Okay, a water company in 2017 was fined 20 million, I beg your pardon, £20,361,000, £140 as well, for environmental breaches. A lot of the things that they were doing, they weren't managing their alarms. They were ignoring alarms. Alarms that were important, they just left because nobody cared. Told them loads of times, nobody ever does anything. Why should we care? The alarms just happen. Nobody responded to them. There were some of the things. There were other things. The magnitude of the fine was because the water company was a repeat offender. They'd been told lots and lots of times, you've got to deal with this. Oh, it's a lot of money. Let's just leave it. Oh, it's a lot of money. Let's just leave it. All of a sudden, they had a £20 million fine. A steel company, one that I did some rationalization with and helped them write their alarm philosophy, was fined £1 million in 2017. I did the work in 2018, 2 years ago. They had actually started 8 years previously. In 2010, they'd started writing an alarm philosophy. Okay, it's a lot of work. We've got lots of other things to do. We haven't got the number of people that we used to have. Oh, we'll keep putting it off. In 2015, managing your alarms became a legislative requirement for plants that fell under the COMA regulations. Lots of the parts of the plant on the steelworks fell under the COMA regulations. So from 2015 onwards, it was a requirement to manage alarms. They should have done all this work. So think about that. Something that I'm not sure is entirely alarm related, because I don't know the full history behind this, but this is an example of, again, the things that can happen. A former oil executive was sentenced to prison and fined $50,000 in 2019, last September, I believe it was, for his role in a 2012 explosion where 3 people were injured. Now, think back to the thing I keep saying. I've told them, nobody listens, nobody ever does anything. Why should I care? He was put in prison because he had repeatedly disregarded warnings from the plant's foreman about things that were wrong on the plant. Now, this is not necessarily just about alarms. There were issues about the way equipment was used, what was there, what wasn't there, etc. But the foreman had repeatedly told the executive, we can't run the plant. This needs fixing. That needs doing. He repeatedly ignored the warnings and said, run the plant. If your operator's coming to you and telling you repeatedly that this is wrong, this needs fixing, and you ignore it, and there's an incident, potentially this could happen to you. Now, I don't suppose, as an oil executive, he really cared about $50,000. It was probably pocket money as far as he was concerned. But I rather suspect he was slightly intimidated at the 18 months he spent confined in jail. I don't think he probably enjoyed that, or the 3 years that he has to do on license. So 18 months in jail and 3 years on license, I think he'd probably be more concerned than the $50,000. But ultimately, that can happen. You ignore things and something happens, you've been told. So should we do things to help our operators, to help manage our alarms properly? In the Europe and UK, if you fall under the Seveso 3 regulations, the COMA 2015 regs, if you fall under those things, you don't have any choice but to manage your alarms. By managing your alarms correctly and appropriately, you are automatically beginning to help your operator. So think about that. In the USA, if you fall under the Code of Federal Regulations, for example, transporting oil and gas in pipelines falls under the CFRs. Managing alarms is a statement, are words in some of the CFRs, the Code of Federal Regulations. It says manage alarms. It's the law, you have to. You don't have any choice. So help your operators by managing your alarms appropriately. I've just said that. It may not be a matter of choice. You may have no choice in the matter because there may be a legislative requirement to manage your alarms. It doesn't tell you how to manage your alarms, but the legislation says you must do it. So think about that. You may need to manage your alarms. It may be a requirement in law. And if you don't, it could cost you money personally. It could cost your company money. It could shut your company down. You might end up in jail. Just think about that. All because you didn't want to help your operator. Your operators are important people. Help them by managing your alarms. By managing your alarms, you automatically begin to help your operator. Okay, so I don't have anything else to say to frighten you. We've got some contact details on the screen there. If you have any questions, I'm sure James will be fielding the questions in a second. If there are any questions from people, all that remains for me to say is thank you for your attention. I hope it's been of use to you and helped to instill in you the thought that actually we do need to help our operators. We do need to start dealing with some of these things. If you need our help, our contact details are on the screen. I'm sure James will reinforce that. And at this point, I shall hand over to James. And thank you all for your attention.
Yeah, thank you, Ian. Some very good information there. As Ian's already mentioned, we'll now open up the presentation for some questions. And if you do have any questions, you can either raise your hand and we'll unmute you, or you can key them into the interface and we'll answer them through the interface. Just give a moment for any questions. Okay, no questions so far. So all that remains is for me to say thank you all for attending. We'll get this webinar uploaded to YouTube shortly, And if you have any further questions or wish to get in touch regarding improving your alarm systems, then please don't hesitate to contact us. And that's everything from us. So thank you and goodbye.